Hello friends, welcome back. Today we are going to start a new chapter, that is chapter number 5, Coordinate Geometry. Now we have already learned graphs in algebra. While learning algebra, we have learned the graphs. So what is the difference between that and coordinate geometry? Actually, no difference. Coordinate geometry is nothing but algebraic approach to the geometry. And what is graph? Graph is just a pictorial representation of that geometry. Now one thing I want to tell you in specific, I have seen papers of lot of students. Though this chapter is very simple, I'll tell you this chapter is simpler than your mensuration or any other chapter. Okay, but students fail in doing the examples correctly in this chapter. Why it is so? Simple thing, because there are 4 to 5 different formulae and different methods for finding out the equation of the line. Okay, actually it's a linear equation in 2 variables which represents your straight line. 2 variables x and y. So any equation in x and y, and linear equation means of the order of 1. So in x and y, if any equation is there, that will represent your straight line. So actually, if the line is given, the equation, finding out the equation of that line is very simple. But you may be given different things. Sometimes you may be given 2 points. Sometimes you may be given the angle theta. Sometimes you may be given slope directly. And you have to find out the equation of line. Or from the equation of line, you have to verify or some point, or you have to do anything. The problem is students don't understand or don't realize when which formula is to be used. Okay, again I am telling you, students get confused in deciding which formula is used when in the coordinate geometry, and unnecessary they lose some marks. Now whenever you are learning something advanced means you have learned that particular thing in the previous year or somewhere else, and now you are learning something advanced. What is the approach to it? What should be your approach? That first we will discuss. For example, now all of you know Microsoft Word, correct? You must have learned in your school computer classes MS Office, in which you must have learned MS Word. Now for example, at your home you have Word version 9, okay, and now in your school, and you are expert in using the Word version 9, okay. Now in your school or in your friend's computer, there is a Word version 11, okay. You are expert in version 9 and now you are learning version 11. So do you need to learn everything again? No, not at all. In that case, what we do? First we check what we know. Okay, the many things are similar to the previous things, and some advanced things are there. Now before moving to actual chapter of coordinate geometry, first we will see what we know about the graphs. While teaching in algebra, I have gone through the same method. First we learned what we know about the graphs, and then we started the chapter. Okay, now let us see what we already know in graphs. So after that our chapter will become very easy. Okay, so what we know in graph? In graph you have all of you know the graph papers. Okay, I am not using graph paper here because here we are not going to actually draw the lines from the points given. We are going to analyze and find out the equations of lines only. So graph paper I am not going to use here. We are just going to use the x and y axis on the plain board. So what we know about the graphs? First of all, we know that there is y-axis and there is x-axis. Okay? Whenever you are going to draw these axes on the graph paper or in your paper, always remember you should draw it perfectly. Show the arrows, show here y, y dash, x, x dash and origin O. Okay? Then we have already learned how to draw the graphs with scales. On your graph paper, there are markings or the squares or the lines are on every centimeter and the small lines are of millimeters. So if I tell you to draw a line of say 25 meters, it is not possible to draw a line of 25 meters on a paper. So what we generally do? We take a scale. For example, 1 meter or 10 meters is 1 centimeter. So whenever you draw 2.5 centimeter line, it will be 25 meters. It will represent 25 meters. But how the examiner will come to know this? That you have taken some scale. So you have to note that scale. So we write scale here. What scale you have taken, that has to be written here. Okay? Now in this case, we know that this is a positive side of the x-axis. This is negative side of the x-axis. We know that this is the positive side of the y-axis and this is the negative y-axis. This we know. What else we know? We know that this is the O, means origin, where the x and y axis intersects, and your graph starts from here and this point is considered as 0, 0. What do you mean by 0, 0? That is the x coordinate is 0 and y coordinate is 0. What else we know? We know that this is called as the first quadrant, second quadrant, third quadrant and fourth quadrant. We also know that if the point is in this quadrant, x and y both will be positive. In this quadrant, x will be negative, y will be positive. Here, x and y both are negative, and in this case, x is positive and y is negative. Whenever you write the points, you have to take care of this. From long back, our school curriculums or standards, we know that whenever you want to draw an angle, that angle should always be taken anti-clockwise. We know this. Okay? We also know that any line is parallel to y-axis. If the line is parallel to y-axis, the equation, it is passing through some point C. Okay, so if the line is parallel to y-axis, is equation of the line is x equal to c. Why? Because in any point the x is fixed, and suppose that the line is parallel to x-axis, its equation is y equal to c. C is constant, any number. This is the intercept. Wherever it intersects, that is your C, on x-axis and y-axis both. This much we know. Okay. Now we also know that not necessarily all the lines are parallel to x or y-axis. Lines are inclined also. Suppose this is my inclined line. Now in this case, what is the inclination of the line? Inclination of the line is nothing but the angle it makes with the x-axis. Now suppose this is my line and it is making some angle here. What is the angle? This is the angle. Let's say this is the angle theta. This is the angle. So anywhere you draw a lines parallel to x and y axis here, the angle theta will be same. Correct? This is called as the inclination of line. Now suppose some line or any other line is parallel to this line. suppose this line is parallel to this line, in that case the inclination of this line will also be theta. Okay, this also we know. Let us go ahead. Now just now we have seen inclination of line. Now this much information we already know. Now let us go ahead. Now let us find out what do you mean by the slope. There is one plane. It is inclined plane, not horizontal, not vertical. It is inclined plane. So what do you mean by slope of this plane? The slope of this plane is nothing but the ratio of its rise to run. Rise means height, run means horizontal distance. For example, the slope of this line is its height, and suppose this is the length, so the slope of the line is equal to h upon L. Okay. Now when h is the rise, that is a right angle, that means this is a right angle triangle, and if this is angle theta, then we know that tan of the angle theta is nothing but opposite side upon adjacent side, and which is nothing but h upon L. This is the opposite side upon adjacent side. So you can write, instead of h upon L, you can also write tan theta. So slope is equal to tan theta. Now let us consider x and y axis. This is my x axis and this is my y axis. I am not writing deliberately x dash, y dash, etc. And suppose this is the line. Suppose this is line AB and this is angle theta. So now what is the slope of this line? It's tan theta. Don't you think that your x axis is also a line? And x axis makes angle of 0 degrees with x axis, of course. So what will be the slope of x axis? Is tan theta. That means the slope of x axis is 0, because tan 0 is 0. And what is the slope of y axis? You know that the y axis is making 90-degree angle with x axis. So what is the slope of y axis? Is tan 90, which is not defined, is infinity. Correct? Now we are going to find out the slope of the line when 2 points are given. Okay. Now suppose on this line 2 points are given. On this line 2 points are given. Let me denote these points by P and Q. Suppose this is point P and this is point Q. This P is x1, y1 and Q is x2, y2. So now what is the slope of this line PQ? Slope of any line is ratio of its rise to run, that means height upon horizontal distance. So I will draw, and for this Q, okay. So now what is the height and what is the length? Let us find out that. Let us calculate that. We have already seen how to find out the distance between 2 points. When one point is x1, y1, another point is x2, y2. What is the horizontal distance? This distance is nothing but y2 minus y1, and this distance is nothing but x2 minus x1. Correct? So what is the slope of the line? The slope of the line is tan theta. Tan theta. Now the slope of the line is also denoted by letter m, small m. Now what is tan theta? tan theta will be equal to y2 minus y1 upon x2 minus x1. That is tan theta, and that is also equal to m, that is the slope of the line. So now in some examples we have this equations, m equal to tan theta equal to y2 minus y1 upon x2 minus x1. Correct? Suppose slope is given, can you find out the theta? Easily. If the theta is given, can you find out the slope? Easily. If these 2 points are given, can you find the theta? Definitely. So now we have got the expression that m, slope of any line, is equal to tan theta is equal to y2 minus y1 upon x2 minus x1, or you can reverse it, y1 minus y2 upon x1 minus x2. In case if x1 and x2 are same, then it will be divided by 0, and whenever in expression divisible by 0 is there, divided by 0 is there, the answer is infinity, not defined. Okay, but suppose y2 and y1 are same, then the answer is 0, and we know that it is not infinity, it is 1, it is 0, tan 0 is 0. Okay, so now examples may be like that. You may be given some point and may be asked to find out the slope of the line. Whenever you have to find out the equation of line, whenever the slope is required to find out, we can use either slope equal to tan theta or by this method, either of this method. If angle is given, you can directly find out by tan theta. If point is given, you can find out by this formula. So this shows us how to find out the slope of any line. Now in this chapter, there are mostly word problems. It may be given that the 3 parallel lines are there. Immediately it should strike to your mind that slope must be equal. Whenever the lines are parallel, slope must be equal. Now suppose they say that the theta, angle theta of the inclination, this theta is 45 degrees. So what is the slope? Tan 45 is 1. Now here again I'll remind you to memorize our 2 triangles by which we can find out the values of the sine, cos, tan, or any trigonometrical identities of 30, 60, 90 and 45. Those 2 triangles you have to always remember. If you don't know about that, please refer to our trigonometric section or your algebra chapters. Okay, so you don't have to by heart the tables for sine 30, cos 30, sine 60, cos 60. You don't have to remember all those values. Just remember 2 triangles. Okay, now whenever the lines are parallel, the slope is same. Whenever the theta is 45 degrees or any other degrees given, then tan theta. If the point is given, then also you can find out the slope. Whenever the parallel lines are there, the slope is same. So in this chapter we will mostly solve the theoretical problems, that is the word problems. So let us see few examples, solved examples for slope of the line. Now before solving solved examples, I'll remind you that on one paper you write the chapter name and you write all the formulas related to this chapter. The first formula we are going to write is m. Don't forget, m is denoted by for slope. M is equal to tan theta is equal to y2 minus y1 upon x2 minus x1. Let us solve few problems. The problems are very easy on this chapter. Just don't get confused between which formula is to be used where. Okay, it is totally depend on what is given. Okay, now for example, the first problem is find the slope of line having inclination 60 degrees. Now in this case also I am not at all going to solve the problems here. We are going to just discuss the problems and you are going to solve the problems. So there will not be any kind of spoon feeding, because if I spoon feed you, if I solve each and every problem here, you will never be able to solve those problems in your exam. Okay, so let us discuss the problems here. The first problem, find a slope of line having inclination 60 degrees. How will you find out the slope? M is slope. M is equal to tan theta. So what is tan 60? Tan 60 is nothing but root 3. So root 3 is the slope of this line. Second one, find a slope of line passing through points A23 and B47. Now you have to find a slope of the line passing through these 2 points. How will you do that? Simple, we know the formula. M is equal to tan theta. Theta is given? No. Then what is the alternative? Y2 minus Y1 upon X2 minus X1. Now remember, in these things, in this chapter there are so many additions, subtractions, multiplication, divisions. So if you are not very good in arithmetics or doing the addition, subtraction, multiplication, division, then it's a problem. So the students who are weak in the calculation part, in arithmetic part, I suggest you take these simple examples of addition, subtraction and try to solve them very fast, because students make mistakes in sign, negative sign, positive sign, or in the division they do mistakes, in the decimal points they do mistakes. So practice that independent of all your curriculum. Practice addition, subtraction, multiplication and division. It's not a joke. I have seen the papers of students, whereas everything is right, their method is right, their formulas are right, but they are missing simple addition, subtraction, division, multiplication. So you should be very strong in your arithmetics, in your calculation part. So the line is passing through point A and B. How will you find out the slope? Simple. M is equal to Y2 minus Y1 upon X2 minus X1. Y2 minus Y1 is 7 minus 3 is 4 upon X2 minus X1, that is 2. 4 upon 2 is 2. So the slope of this line is 2. One more example. Find the slope of the line passing through points D and E. D is given minus 6, minus 2, E is given 5 and 4. Simple example. Okay, just one point is in the minus 6, minus 2, means in the 4th quadrant. That's all. Calculation part, there is no difference. We have to use the same formula as Y2 minus Y1 upon X2 minus X1. One more example is there. Find the slope of the line L passing through the points. Again 2 points are given. Same method, same formula. So don't expect such simple examples in your paper. If at all it is there, it will be only for 1 mark. Okay. So you have to use the same formula. The slope of the line can be negative. Okay. Slope of the line can be negative, can be positive, can be fraction. Now suppose the slope of the line is minus 1 upon 2. Don't write minus 0.5. Just keep it as minus 1 upon 2. Okay. Next, show that the points P 30, Q6 minus 2 and R minus 3, 4 are collinear. What do you mean by collinear? Lying on the same line. Okay. Now if you want to show that these 3 points are collinear, what you will do? If they are on the same line, the slope of that line will not change. That means, you know that if this is the line and these 3 are the point P, Q and R, I can write the name of this line as line PQ or line PR or line QR. Correct? But the line is same. So what you have to do? You have to find out the slope of PQ, slope of PR and slope of QR. And you have to show that all these 3 slopes are same. That means y2 minus y1 upon x2 minus x1, y2 minus y1 upon x2 minus x1 and y2 minus y1 upon x2 minus x1. You have to find out the slope of these three lines. M is equal to y2 minus y1 upon x2 minus x1. When you show that the slope of all these three lines are same, that means the points are collinear. This example is quite common and quite famous for the October papers. Now, instead of finding out the three slopes, you can find out the PQ and QR. You can find out the slope of only these two lines, PQ and QR. If those slopes are same, you can simply say that point Q is common for PQ and QR both. And since the slope of these two lines are same, these points are collinear. Or you can find out the slope of three lines and then say that these points are collinear. Okay, let us go ahead. If the slope of line joining points 2k and minus 3, 0 is 2 by 5. Find the value of k. This is very simple but famous example. Slope is given, m is equal to 2 upon 5 is given. Points are given 2k and minus 3, 0. Whenever they say, see, now we are going in order. You know that these are the examples of slope. So you know which formula is to be used. But in exam, all the questions are random. At that point, now you have to decide which formula shall I use. They say slope is given. For slope, we know only two formulas. Tan theta, y2 minus y1 upon x2 minus x1. 2 points are given. So second formula is to be used. Correct? Now in this case, 0 minus k upon minus 3 minus 2 is equal to 2 upon 5. Can't you find out the value of k in this case? Very, very simple. 2 upon 5, that is slope is given, 0 minus k upon minus 3 minus 2. Now in this case, whenever so many minus signs comes into picture, the students are tend to make mistakes. Do not make sign mistakes. That is the silliest mistake any student can do. Okay, so let us solve this example. This is nothing but 2 upon 5 upon minus k upon minus 5. So k is equal to 2. After solving this, you have to write down in the square or bracket the final answer. The k is equal to 2. That will be your answer. Okay, I have just shown you this example. Actually, I should not solve this because this is very simple. So in future, I am just going to discuss such kind of examples, not going to solve on the board. Okay, let us go ahead. The problem is, show that quadrilateral ABCD. In quadrilateral ABCD, show that this ABCD is a parallelogram if its vertices are A 48, B 55, C 24 and D 17. You have to show that this is a parallelogram. So suppose this is ABCD, A, B, C and D. Vertices are given. How will you prove that this is a parallelogram? What is the quality of parallelogram? Opposite sides are parallel. We have two pairs of parallel lines. The A is given 48, B is given 55, C is given 24 and 17. 24 and D is 17. We will find out the slope of all four lines AB, BC, CD and DA. Okay, just quickly find out the slopes of all these four lines. Please pause your video here and find a slope. The slope of the line AB is minus 3. Slope of the line BC is 1 by 3. BC is 1 by 3. Slope of the line AD is 1 by 3. AD is 1 by 3. And slope of the line CD is minus 3. So the answers are AB is minus 3, BC is 1 upon 3, AD is 1 upon 3 and CD is minus 3. Now if you see AB, the slopes of AB and CD are same. So AB and CD are same. So AB and CD must be parallel lines. Slope of AD and BC are same. So BC and AD must be parallel lines. Hence, it is proved that this is a parallelogram. Simple example, you have to just find out the 4 slopes. That's all. Slope of the 2 lines, a pair of lines is same. So that is a parallelogram. Simple examples. Let us now go to exercise 5.1. Thank you.